Okay, let's see how you did on the balloon problem. Okay, we're looking at the height in meters of a balloon on the y-axis compared to the number of minutes that have gone by on the x-axis. Okay, so at 0 minutes, the balloon is 16 meters high. After 1 minute, the balloon is 14 meters high. After 2 minutes, the balloon is 12 meters high, and so on. Okay, so first we want to find the slope. The slope means change. Okay, slope means change. But when you have a graph, the way to find that slope is rise over run, going from one point to another. Remember, the closer the points, the easier. Okay, so I'm going to go from here to here. I'm going to rise and run. Okay, so when I rise, I go down in this problem. I'm going down. Careful at your looking at your numbering, because I'm numbering by 2 on the y-axis, right? So I'm going down 2 meters. So my rise is negative 2 meters. Down's negative. And then I'm going over to the right. Okay, the x-axis is numbered by ones, like normal. Okay, so I'm going over 1 minute. Use the label there, 1 minute. Okay, so my slope is negative 2 meters over 1 minute. I'm going to take negative 2 divided by 1, which is negative 2, and then put meters per minute after that. Okay, so that's the slope. Okay, so slope, the regular number slope is negative 2. But what that means is that balloon is going downward 2 meters every minute. Okay, it's the change. It's the change in height. So I'm just going to put going down. The balloon is going down 2 meters per minute. Okay, y-intercept. Y-intercept is the initial amount of stuff. Or in this case, it'd be the initial height. Okay, for a y-intercept of a graph, it's just where it crosses the y-axis. Okay, the y-intercept would be 16. And what that means is the balloon starts out at 16 meters in height. So I'll put the y-intercept is 16. The balloon starts at 16 meters high. Okay, so negative 2 is your slope. 16 is your y-intercept. Okay, the equation, y equals slope always goes in front of your x. The y-intercept always goes at the end. So I'm going to put negative 2 in for the slope, 16 in for the y-intercept. Okay, think about this a minute. Y is height. X is minutes. So this equation means the height, y, is equal to negative 2 times the number of minutes that have gone by, because it's going down 2 meters every minute, plus the 16 meters that it started at. Okay. How high is the balloon after 7 minutes? If you really wanted to, you could just try to keep going. At 6 minutes, using the graph, it'd be at 4. And then at 7 minutes, it would end up being at 2. So it's going to be 2 meters high. But what I was hoping also you could do is take that equation, plug in what you know, solve for what you don't know. Okay, they're asking you how high. They're asking you for y, because y is height. Okay, they're giving you 7 minutes. Okay, minutes is x. They're giving you that x is 7. So I'm going to take that equation. I'm going to replace x with 7. And I'm going to bring the entire rest of the problem down. And I'm going to solve for y. Okay, it's easy to solve for y because y is already alone. All I have to do is compute the right-hand side. Okay, multiply before you add. Okay, negative 2 times 7 is negative 14. And then add 16. And that gives us 2 meters high, which is what we had just by looking at the graph. Okay, let me know if you have any questions.